Hello boys and girls, Mr. Giomini wanted to come to you with a couple examples of how to solve equations when we have decimals. Now we've done a nice job of solving equations with whole numbers, we've done it with integers, now we're going to look at decimals. And now these decimals may be positive or negative. That doesn't make them an integer. Remember, integers are the whole numbers and their opposite. So don't think that because we just slap a negative sign in front of something that they're all integers. Remember, integers are whole numbers. I'm not going to do all of these, but let's just take a look at a couple of them. So looking at this page, a couple ones that might make us uncomfortable here. Let's look at number 14. And I'm just going to rewrite these down here. We have 41, and 96 thousandths is equal to 4 and 6,700ths times x. So I notice on the right side of the equation I have my coefficient and variable. On the left side I just have this number. Well, I want to evaluate for 1x. I'm not really concerned with 4 and 6,700ths x's are. I know that they're equal to 41 and 96 thousandths. Well, the opposite of multiplying is to divide, so I will now divide both sides by 4 and 6,700ths. Now, as I'm doing this, I'm automatically thinking I cannot have a decimal in my divisor. And I know that the divisor is a number that goes on the outside. And in this situation, this is the divisor. This is the dividend. So if I notice that this has to be moved over once and twice, making this really 467. And what am I dividing into 467 parts? Well, because I made two moves to the right with this, I must also do it in my dividend. So I'll move the decimal 2 places to the right. This becomes, now no longer is it 41, it's now 4,009 and 6 tenths. So now I have a hard time dividing like that. I'm going to go over here and write it like this. I have 4,109 and 6 tenths on the inside, and that's to be divided by 467. First thing I'm going to do is place my decimal up in the quotient. Now, 467 will not go into 4, it'll not go into 1, it'll not go into 0, but it will go into 4,109. Now, if I were to multiply this by 10, which I can't put a 10 up here, that would give me 4,670. Too big. I could try 9, which would be 4,670 minus 467. That's 3, that's 0, that's 1. Hey, that looks like it's real nice. So I'm going to put the 1 right here. Or excuse me, that goes in 9 times. So I'll put the 9. 9 times 7 is 63. I'll put the 3 here. 9 times 6 is 54, plus 6 is 60. 9 times 4 is 36. Oh, plus 60. That gives me 42, doesn't it? So I don't think that's going to work. Ah, must have did some wrong math over there. Let me erase this here. Let's see. It's always nice to make a mistake on a video. Let's try 8. 8 times 7 is 56. 8 times 5 is, or 8 times 6 is 48. Plus the 5 is what, 53? That's 32 plus 5 gives me 38. 32 plus 5 gives me 37. There we go. End of the day here making this video. I guess I'm struggling. I'm going to bring down the 6 right away. 9 minus 6 is 3. This becomes a 10. That is then a 10, and this is a 3. 10 minus 3 is 7. 10 minus 3, or 7 is 3. All right, so I have, now really if I covered this up, or was able to get rid of this, I would know I'm okay because my remainder is less than my divisor, so I'm okay. I'll put the 6 here now. Oh, look at this. 3,736 left over. Look what I just did when I multiplied 8 times this. It gave me that exactly, so I know my answer is 8. So for this one here, we would say that x is equal to 8 and 8 tenths. Again, as you saw me making a video, real easy to make a calculation mistake on this. Don't do what I did and make a mistake. But if you do make a mistake, do what I did and catch a mistake. All right, let's look at another one. I was really intrigued by, where's that one I saw? I liked 15. I also like 20. But let's do 15. The 15, I'm going to rewrite it, is 17 and 52 hundredths minus z is equal to 4 and 1300ths. Now watch what I'm going to do with this one. Obviously the variable is z in this, but you know what? See how they're subtracting z? Which means, again, think about keep, change, change. This becomes a negative z. I don't want to solve for negative z. So what I'm going to actually do is I'm going to add a z to both sides. I'm going to add a z to this side. Now when I do that, this z's gone, leaving me with 17 and 5200ths is equal to 4 and 1300ths plus z. Now I can solve for z without worrying about having to be in negative. I'm going to isolate that variable over here. I use the word isolate now rather than evaluate because we're not using multiplication or division. We're using addition and subtraction. I am now going to get rid of the 4 and 1300ths. Well, to do that, I'm going to subtract it from both sides. So minus 4 and 1300ths. Minus 4 and 1300ths. Now, if I did a little estimation here, I really have 17 minus 13, or excuse me, 17 minus 4, which would give me 13. So I know my answer should be somewhere around 13. That is gone. I'm just left with the z now. So z is equal to, that becomes a 12. This becomes a 4. 12 minus 3 is 9. 4 minus 1 is 3. 17 minus 4 is 13. So I should have 13 and 3900ths. So up here I would write z is equal to 13 and 3900ths. Let's take a look at another one. What else could we do up there? Let's find one. I like, let's take a look at number 24. We have a division and we have a negative number. Again, not an integer. It's just a negative decimal. That gives me W, some numbers broken up to parts that are less than 1, less than 1/10, less than 100. That's 56 10,000ths. Tenths, hundreds, thousands, 10,000ths is equal to negative 4 and 7/10. All right. Now, obviously, I see on the left-hand side of the equation here, I want to solve, well, what is it that I divided up into this 56 10,000ths pieces to get negative 4 and 7/10? Well, as I'm thinking here, my answer has to probably be bigger than 4 and 7/10 because I broke up a big thing into these little small pieces and came up with that. Well, the opposite of dividing both sides by this is to multiply. So I'm going to multiply by 56 10,000ths. Multiply by 56 10,000ths. This is kind of a tedious one to write. I notice I'm multiplying a negative by a positive, so I know my W's are going to be a negative answer. Signs are opposite. Let's just put, because the 56 10,000ths has more digits, let's put that on top, and let's multiply by the negative 4 and 7/10. Now I'm not going to put the negative there because I already know my answer is negative because I'm multiplying a negative times a positive. 6 times 7 is 42, I believe. 7 times 5 is 35, plus 4 is what, 39, I believe? Is that right? That gives me, now I am done with that 6. I'm going to put an x here to hold a place value. I'll put a 0 here to hold that place value. We're now going to look at 6 times 4 is 24. 5 times 5 is, or 5 times 4 is 20, plus 2 is 22. Let's take a look. My theory was wrong before, wasn't it? Yeah, absolutely. I said, oh, this is going to be bigger than negative 4 and 7/10. But it's not, is it? Well, let's take a look. 2 plus 0 is 2. 9 plus 4 is 13. 3 plus 2 is 5, plus 1 is 6. And then we get a 2 here. Move the decimal place over once, twice, 3, 4 times, and 5 times. 1, 2, 3, 4, and move one more, and that is 5 times. So I have W is equal to negative 2,632. Right? 2,632 tenths, hundreds, thousands, 10,000s, 100,000ths. Wow. Now let me ask you a question. Which number is closer to 0? Negative 4 and 7/10 or this one? Which one's closer to 0? This is closer to 0, isn't it? Yes, it is. So, meaning that, yes, I was right in my answer. And we can always use this. Let's just double check because my answers look really weird. And sometimes I get a weird answer. It's not a bad thing to check with the calculator. So let's see here. We know the answer is negative, so let's just ignore the negative. So we have 0 and 0, 2, 6, 3, 2. That says 2,632, what, 100,000s? Tens, 100,000s, 10,000, yep. Divided by And we divided that by 0 and 56 10,000ths. We get 4 7/10. And we talked about how that'd be negative. All right, now again, I use the calculator because, you know what, let's say I'm doing my homework and I want to check to see, you know what, that seems like an odd answer, and I double checked it. You know what, I was right. Always feels good to know you're right. All right. Hope this helps you out a little bit. Let's try one more. Let's just try one more. We will try one more equation problem here. That was a pretty tedious one. Let's take a look. So we did a multiplication one. We did one we're subtracting. You know what? Let's do number 20. So we have v minus 4 and 25 thousandths is equal to 1 and 9,024 hundred thousandths, 10,000, excuse me. Now, see here we have this v by itself. We want the v by itself. We can isolate that. Notice I'm not going to add it to both sides because it's a positive v. But what I will do is I'll add the 4 and 25 thousandths to both sides. Now when you add decimals, make sure you line the decimal points up and then line up their respective place values. Put a 0 here to hold place value. We'll go here. We have 4 plus 0 is 4. 5 plus 2 is 7. 2 plus 0 is 2. 9 plus 0 is 9. That is 5. That would be gone. So v is equal to 5 and 9,274 10,000ths. All right. I hope this helps you out as you begin to prepare for your post test, which is never too early to do that. Take care. Bye.